Hello, class. We're starting the second part of the midterm exam review. We did the first part yesterday, and I sent you all the link to it on YouTube. But if you wanted to watch the video on Big Blue Button, it's broken up into two parts. Now, just like yesterday, when we went over the midterm review, just like I have here, we will go to the same area on JetNet, but when you scroll down to the bottom of this review, it also has the answer key, just like the previous review. Now, what we're going to do today, aside from doing the review, I want to talk to you all about Monday and Tuesday of next week. Now, again, you will have your midterm over the 2 days unless it was discussed and we made other arrangements. But with that midterm, you will get an hour to take the midterm part one on Monday and then an hour to take part two on Tuesday. And the midterm starts at noon to 1 p.m. Again, from noon to 1 p.m. And I must add a caveat to that, unless we made other arrangements. There's a couple of you that I had to make other arrangements with, so you have the arrangements we made in the email. Now, the next thing, we want to talk how to access Zoom. I am going to send out an email to you all, possibly by 11 a.m. on Monday, and also Tuesday 11:30 a.m. I will send you the link to the Zoom session. Now, if you do not get the link and say you don't have access to your email or something like that, there's another way that you can access the Zoom session. Now I'm going to show you this. I need to bring this over, and I'm going to show you this here on JetNet, how you could access the Zoom session on JetNet if you do not get the email. What you could do is scroll down until you get to office hours. The link that I use for office hours is the same link that you would use for the Zoom session for the exam. But remember, the exam starts at noon. This right here is listing my office hours. So if you click on the office hours link, it will take you to the Zoom site. And then all you have to do is wait for me to give you interest until Zoom. So you can either use the link I'm going to send you, or you could click right here for the office hours. Also, for the midterm, there is a password for the midterm for both days. I will give you the password once you sign into Zoom and once I see you on the camera and your workstation. Once I see all of that, you are to leave your camera on as you are taking the exam, and I will give you the password. Now, you only have the time allotted. So I said the time ends at 1 o'clock. If you come into the class at 12:45, you only have 15 minutes for the midterm. So I'm just letting you know it's a 1 hour time frame unless I made other arrangements for you. And just to clarify, when I made the other arrangements for students, just to be transparent, I allowed them to take the midterm. They're going to take it in one day. So they're going to get 2 hours, basically an hour for both midterms. So they're still going to be allotted the same amount of time that those of you that are taking it on Monday and Tuesday will be allotted. You'll get a total of 2 hours, an hour for part one, an hour for part two, and they will get a total of 2 hours time, an hour for part one, an hour for part two. So it still will be the same amount of time. They're just doing it in one day instead of over 2 days. So just to let you know the distinction there. So that is basically it. And then also, if you don't know where the exam reviews are, They're right here on the JetNet page. You just click here, and then the exam reviews show up here. So midterm, we did part 1 yesterday. You could click on part 2 today, and then download the midterm review. Now I want to go over this review here. And then also one last thing with the midterm, you are allowed to use 2 sheets of notes. Whatever you put on those two sheets of notes is fine. So you're able to use 2 sheets of notes front and back, your calculator. You can use the Desmos calculator, or you can use a standalone calculator. It's totally up to you. So now we're going to get started with this review. It says here, short answer. Write the word or phrase that best completes each statement or answers the question. Number 1, write the ratio in lowest terms. So we have number 1, the ratio is 16 inches to 32 inches. So it'll be 16 inches. The word 2 means division. So it'll be divided by 32 inches. The inches will simplify out. And you could simplify these by dividing both by 16, or we could go right here to this Desmos calculator and type in 16 divided by 32. And then we will press this button here, and then it will give us 1/2. So this will give us 1/2, or you could write it as 1 to 2. Either one of these are fine. Okay, number 2. A coyote can run 112 meters in 5.9 seconds. A jackrabbit can run 53 meters in 3.3 seconds. Compare their unit speeds to determine which animal is faster. Round to the nearest whole number. Okay. So for number 2, for the coyote, I'll just put C. So it'll be 112 meters in 5.9 seconds. And then the jackrabbit, I use a J. It'll be 53 meters in 3.3 seconds. So what we could do is put this right in our calculator. And we have 112 divided by 5.9. So that gave us 18.98. And then 53 divided by 3.3. So for the coyote, it's 18, we're rounding 2 decimal places, 18.98 meters per second. And then for the jackrabbit, it's 16.06 meters per second. Now, if you notice, the coyote is faster because it covers more distance per second than the jackrabbit. So it'll be coyote is faster. Okay, now we move on to problem number 3. I'm going to save 3 for later because this requires me to draw a chart and plot the points. So we'll come back to 3. Okay, for problem 4, it says find the unit cost to 3 decimal places. Okay, so we have $6. A bottle of shampoo costs $6.49 for 12 ounces. So we'll divide that by 12 ounces. Now, whenever you deal with unit costs, it's dollars divided by the units. So we'll take 6.49 and divide it by 12. And they tell us to round to 3 decimal places here. So it'll be approximately 0.541, and this is dollars per ounce. So that is the unit cost. Okay, now for problem number 5, it says write the ratio in lowest terms. So we had 10 meters divided by 2 meters. So this will give us, the meters will simplify out. This will give us 5 over 1 because a ratio is typically written as a fraction, or we could write it as 5 to 1. Either one is fine. Okay, now number 6. As a matter of fact, let's take a look here at the answer key. And let's see how the answer key put it. Yeah, they left it as 5/1. Okay. So the reason why I wanted to look at the answer key was because even though both of these are equivalent, you should start off with the fraction first. Okay, number 6. Write the rate as a unit rate rounded to the nearest hundredth. Ceramic tiles sell for $12.74 for a box of 12 tiles. Find the price per tile. So the price is $12.74 and the tiles are 12 tiles. So we will put this in our calculator. 12.74 divided by 12. And that would give us, they tell us to round to the nearest hundredth. So that would be 2 decimal places. So that would give us $1.06 per tile. All right. Now we come here to problem 7. It says, what type of growth is shown in the table below? Linear, exponential, or neither? Growth is linear or exponential. Oh, it's missing a word here. It says, if growth is linear or exponential, then find the next 3 values. Now, if we look here, to go from 50 to 53, well, first of all, we look here. We notice that this is going in numerical order. Start will be the 0 month, 1, 2, all the way up to 5 months. Okay, so this is going in order by 1. Then we come here to go from 50 to 53.50. That will give us $3.50 that was added here. But if you notice, this went up to $4 here. Then this went up to $6 here. So it's not going up at a steady rate. So we know it's not linear. So now what we would need to do is see whether or not it's exponential. And if it's not exponential, then we would pick neither. Okay, so we know that it's not linear. But with exponential, we have to be able to multiply by the same consistent values in order for this to work. So what I'm going to do, I'm going to take this Desmos calculator here, and then I'm going to go through each value like we did before to see the growth factor or growth rate. I would rather do the growth factor. That'll make it a lot easier. So we'll take the 53.50 and then divide it by the 50. So that gave us 1.07. So we'll do 57.50 divided by 53.50. Now this is still 1.07, so we're still doing okay. So let's try the 63.50 divided by 57.50. Now it went up to 110. So you notice here, we could stop right here. Like these two were approximately 1.07 if you do it to 2 decimal places, but this is 1.10. So this is not consistently exponential either. So your answer here for number 7 would be neither. So number 7 would be neither. Okay, number 8. It says the equation y equals 81.6 times 1.013 to the x can be used to model the population of a country and millions of people based on the number of years since 1900. Identify the variables in this equation. Now y is the variable and also x is the variable, but we have to tell what they mean. Okay, so y is the population since 1900. That's what y is. Y is the population since 1900. And then X is the number of years since 1900. So that took care of the variables in this problem. Okay, number 9. In blank growth, each element of a list of numbers can be found by adding a constant number to the previous element. That's linear. Linear growth, you add. Exponential growth, you multiply. Okay, number 10. For one particular data set, both a line and an exponential equation of best fit are found. Find the line. The value of r is 0.403, and for the exponential, the value of r is 0.977. Which type of equation is most likely the better choice for the data? The r equals 0.977, which is the exponential equation, would be best because the correlation coefficient is closer to 1. So that's why it's the better choice. Okay, now we come to 11. It says for the data points listed below, find the line of best fit and the correlation coefficient. Okay, so this is what we would need to do. And I'm going to have to pull this Desmos calculator over here. We're going to have to do a table for these values here. And after we do the table, I'm going to show you what else we need to do. So we need to type in these values. The x values, we have 2, 4, 6, 8, 10, 12, and 14. Now we go to the y values. We have -5, 10, -1, 11, 7, -10, and 6. Okay, these are our y values. Okay, now we're going to put this in as a linear value and also as exponential to see which one is best. So we know for the linear is y equals mx plus b. So we'll do y1, and then we would do this tilde, mx1 plus b. Because remember, when we look back up here at the table, it's x1 and y1. So that's why we put the sub 1s here. So now we look here at the correlation coefficient is 0.009623. So now we can use the same information to find the exponential. So we know the exponential equation is y equals a times b to the x. So we'll have y1, the tilde, ab, and then we have to take that to the x1 power. And if you notice here, we don't have that log. We usually have a log button we have to push, but we don't have that here. So if you notice here, we don't even have a regular R. So the linear would be the better, would be the one we would use. So it'll be linear. So this is number 11. It'll be linear because they ask us which is the best one. And then our correlation coefficient will be R is equal to, and we could round to 4 decimal places, 0.0096. Because they ask us to find the line of best fit in the correlation coefficient. So the line of best fit is linear. The correlation coefficient is R equals 0.0096. And then we also will put in the equation. So the equation would be y is equal to the slope We could round to 3 decimal places. It's 0.018x plus 2.429. And that will be your final answer. It's linear, correlation coefficient, and we have the equation here. All right. Now we go to problem number 12. Problem number 12. It says when finding the line of best fit using a graphing calculator, the last line in the display should be a value for a quantity labeled R, which is known as it's the correlation coefficient. So that's it for problem 12. 13. Well, this number measures how well the line seems to fit the data. Okay, 13. Suppose you bought a used car for $28,000 a few years ago and its value has been decreasing at the rate of $2,100 per year since then. Write an equation that represents the value of the car in terms of the number of years since it was bought. Make sure you clearly identify what each variable in your equation represents. Okay, first of all, we know this is going to be linear because it's decreasing at a steady rate of $2,100 per year. So we know that it's subtracting by that amount. So we will have y equals, the equation would be the mx plus b. Y is equal to, the slope would be the decreasing rate, which is a negative 2,100. And that'll be x. We don't have to put the dollar sign here. So it'll be a negative $2,100 x. And then plus the initial cost of the used car, which would be $28,000. So now it also tells us to make sure you clearly identify what each variable in your equation represents. Y is equal to the total value of the car after depreciation. And then X represents the years since the car was bought. And I couldn't give a definitive year because it doesn't say the year on this on here, but it's the year since the car was bought. Okay, 14. Radioactive elements are good examples of substances that decay exponentially. Iodine 123 decays in such a way that 95% of the initial sample remains after each 1 hour period. If an initial sample is 240 milligrams, write an equation that describes the amount remaining after X hours. So if you look here, it tells us that we're doing a decay exponentially. So we know we're doing y equals ab to the x because that's the exponential equation. So now we're going to do some substitution. A is the initial value. The initial value in this problem is this 240 milligrams. So A would be 240. Now B is the growth factor. So it tells us, or the decay factor is 95%, so it'd be 0.95, and then it'll be taken to the x to give us the time period. So that would be your equation. Now problem 15. An investment whose value is described by the equation y equals 11,000 times 1.04 to the x is left untouched for many years. After 3 generations of inheritances and 93 years, how much would the account be worth? Okay, so we have y is equal to 11,000 times 1.04 to the x. Now x is representing years, and it says that it's been sitting there for 93 years. So we could substitute in for x as 93. Now we could take our calculator and we could take 11,000 parenthesis 1.04, and then we could take this to the 93rd power. So your answer here would be $422,175.71. That's how much money would be in the account after 93 years. All right, problem 16. It says for one particular data set, both a line and the exponential equation of best fit are found. For the line, the value of r is 0.971, and for the exponential, the value of r is 0.312. Which type of equation is most likely the better choice for the data? So for 16, it would be the line, or you could say linear. The linear equation is better because r equals 0.971 is closer to 1. All right, now we go here to problem 17. It says canned pumpkin comes in two sizes, 29 ounce and 15 ounce. The larger can costs $1.39 and the smaller can costs 79 cents. Find the unit cost of each can to 3 decimal places to choose the best buy. Okay, so this is what we would do. Remember, we're doing unit costs. So we would do, I would put L for the larger can and S for the smaller can. Okay, so the larger can, it was $1.39 for 29 ounces. The smaller can was 79 cents for 15 ounces. Because remember, when we're doing unit prices, we always do the cost first, and then we would do the units. So now we'll type in 1.39 divided by 29. So we'll round this to 3 decimal places. It'd be 0.048. And that'll be that cents per ounce. And then now we would do 0.79 divided by 15. So this would be $0.053 per ounce. Now we're asked to choose the better buy. The 29 ounce can is the better buy because of the lower unit cost. Now problem 18. It says the table below shows the number of women serving in the legislature for selected years. Find both a linear and an exponential model for the data and decide which model is a better fit for the data. Round coefficients to 5 decimal places. Now listen, I will tell you this. The way how we could tell which one is the better fit, we will use the correlation coefficient. But we must enter these values in. And what I want to do, I'm going to move this calculator over again. Now I want to show you something that I did that you may not have paid attention to, which is fine. If you notice, I left here the exponential equation and I left the linear equation. And the reason why I do that is because if you leave these two equations here, all you have to do is change this table and then it will automatically give you the linear and exponential values. So let's test that. So now, according to this, the years have been replaced by X because this is since 1980. So we would change our X values. Matter of fact, I could just delete all this out. So we would have 0, 2, 4, 6, 8, 10, 12. It went up to 14. All right. Now we have 18, 20, 20, 21, 22, 24, 25, and then 32. All right, so now we put all those values in. Now that I put those values in, now we can take a look here. Now, first of all, we look here at the linear equation because remember, they want us to write out both equations. So we can write the word linear, and then the equation would be y is equal to 0.8095x. I'm going to go to 4 decimal places, plus 17.0833. That would be the linear. The exponential will be y is equal to. Now, we go down here to the exponential. Now that log box finally shows up, we have to click it. And then now we have these values. So A, again, we're going to round to 4 decimal places. It'll be 17.6543. Then you have your parenthesis, 1.0347 taken to the x. Now we have our two formulas here. Now we're asked to determine which model is the better fit. Okay, so now we go here to the model, we look at the R values. For the linear, the R value is 0.9081. For the exponential, the R is 0.9393. So our answer would be exponential is the better fit with the higher correlation coefficient of R is equal to 0.9393. And that will be your final answer for problem 18. Now we move on to the next page, to problem 19. It says for problem 19, would a linear model or exponential model be a better choice? It'll be exponential. And you can see that it has the exponential curve. Oh, you know what? I misspelled exponential. Exponential. Yeah, it'd be the exponential. So now, for problem 20, if Kate bought a sofa for $780 and plans to make 12 payments, what is the amount per payment? So for 20, we would take $780 divided by 12. So we could do that. $780 divided by 12. So it'll be $65 per payment. Okay, now we go to 21. Find the slope of the and y-intercept. So the slope here would be 18. And the y-intercept, you could put b or you could write the word y-intercept. If you write, you could write either negative 43 or you would write it as an ordered pair. Either one of these are fine. Now, for 22, it says the table below lists the average tuition cost for all public American colleges and universities for a variety of school years starting in 1981. Using a graphing calculator, you find the exponential equation of best fit for your equation to be y equals this here. Write a description of what the base of the exponential in your exponential model tells you about the growth of tuition since 1981. Okay, so they want us to find the base or the B. The B here is already given to us. Okay, so they want us to tell about what does the growth mean for the tuition. So first of all, we know that that is the growth factor. We want the growth rate. So to get the growth rate, we have to subtract 1, and then we need to change this to a percent. We'll move this 2 decimal places to the right, so it'll be 5.66%. And since it's positive, we know that tuition grew 5.66% per year since 1981. That's what it tells us. Okay, problem 23. It says when finding the line of best fit, the correlation coefficient will always be between -1 and +1 inclusively. So whichever value you get that's closest to one of those numbers, that is the one that will be the better fit. Okay, 24. It says, what type of growth is shown in the table below? Linear, exponential, or neither? Let me see. It says if the growth is linear or exponential, then find the next 3 values. Okay, first of all, we always check to see if the growth is linear. We notice that these are, in order 1 unit apiece, because this would be 0, 1, 1 through 5. Okay, so if you look here, this went up 3,400. And then if you notice, this next value did not go up 3,400. So we know that it's not linear. So now we're going to check and see if it's exponential. So to see if it's exponential, I would just do the growth factor. So if the growth factor is the same, then we're good. So we had 20,400 divided by 17,000. And that gave us 1.2. So then we could do 24,480 divided by the 20,400. That gave us 1.2 as well. So now let's go to the last value. So we have 42,301.44 divided by 35,251.20. And it gives us 1.2. So we know it's exponential. So we know it's exponential. And then we're asked, it says here, they want us to put down the next 3 values here. So if we do the next 3 values, all we have to do is multiply these by 1.2. So we would take the 42,000, I guess I pulled this back premature. We would take the 42,301.44 and multiply by 1.2. So one of the next 3 values would be this 50,761.73. Then we would take that value, the 50,761.73, and multiply by 1.2, and that would give us 60,914.08. And then we would take that value, the $60,914.08, and multiply by 1.2, and that would give us $73,096.90. So that would give us our three values, and I took the liberty and wrote it here for the next three values. Okay, now we move on. That was problem 24. We go to problem 25. The equation y equals 81 times 1.013 illustrates blank growth, and that would be exponential. So it'd be exponential. 26. Classify the pattern as either linear or exponential growth. So for 26, you got 1, then you go to 2, then 4, then 8. If you notice in here, everything is doubling. So then that would be exponential. Okay, 27. Classify the pattern as either linear or exponential. Now we know it wouldn't be linear because as we go along, we end up with some decimal values here. So then we would have to do exponential. So what we could do is this here. We could take the 816 divided by 800, and then we get 1.02. So we could take 816 times 1.02, and it gives us 832.32. And then we can multiply that. Hold on, give me 1 second. Okay, so we'll take this 832.32 and multiply it by the 1.02. And the reason why I did it this way is because we could look at these next two values to see if they match up. So we got 832.32, then we got 848.9664. So we know that this is also exponential. All right. Problem 28. The table shows an example of linear growth. What is the next value on the list? Okay, so it tells us that this is linear growth. So if you look here, this is going up by 7. So they ask us what's the next value on the list. So we'll take 64 plus 7. So then that would be 71. Okay, 29. The growth rate of y equals 80.25 times 1.014 to the x with x in years is blank percent per year. So what we would have to do, we would take that 1.012, subtract 1, and then make this into a percent. We'll move 2 places to the right, so it'll be 1.2%. So that's the growth rate. Okay, problem 30. The equation y is equal to 81.15 times 1.012. Oh, you know what? I made a mistake. I actually took the value out of the parenthesis for 30 for 29. This is supposed to be 1.014. So this should be 1.4%. That was a little error on my part. Okay, it says here for 30, the equation y equals 81.15 times 1.012 to the x can be used to model the population of a country and millions of people based on the number of years since 1900. What is the significance of the parameter 81.15 in this equation in terms of population? So basically, it's saying that the population, because remember that's the starting point, the population in 1900 was 81.15 million people. That's the significance. Okay, 31. It says write the ratio in lowest terms, 27 cents to 3 cents. So we add 27 cents to 3 cents. So the cents will simplify out, and this will give us 9 over 1. Now remember, the only reason why we're leaving this fraction in this way is because we're doing a ratio. We typically do not leave a value over 1, but this is a special case. Okay, problem 32. A lemonade stand serves several beverages in different sizes and each contain different amounts of sugar. Determine which of the beverages contains the greatest amount of sugar per fluid ounce and indicate the amount. Round to 2 decimal places. All right, for problem 32, what they want us to do, and we could use our Desmos calculator. We don't have to write this out. We could use the calculator. They want us to know how many grams of sugar it is in each one of these and which one is the greatest. So they want sugar per fluid ounce. So we could do the first one. We have 66 divided by 21. The second one, we'll do 61 divided by 15. The third one, we would do 40 divided by 13. And then finally, the last one, 32 divided by 9. Okay, now, 3 of the 4, the first, the third, and the fourth all has 3 point something for their answer. But the second one, which is the fruit punch, has 4.07. They tell us to round to 2 decimal places. So we would say it's the fruit punch. And then, let me move this back over here. It's the fruit punch, and it's 4.07 sugar per ounce. That's a lot of sugar, or it should be grams of sugar. So I could just put 4.07 grams per ounce. That's grams of sugar. Okay, 33. Find the next entry for the pattern shown below. Okay, so we always try and check and see if it could be a linear pattern where we add or subtract. You notice here we added 9.5. If we add another 9.5, that gives us 819. Another 9.5 would be 828.5. So we want the next entry, so we'll add 9.5, and then that would give us 838. Okay, problem 34. It says find the next entry for the pattern shown below. So if you notice here, we do addition, it went up 40 here, but then it went up 48 here. So we know that it's not addition. So then because this is a pattern, we could find out what it is. We could take the 240 and divide it by 200. So it'll be 1.2. So we'll have to take 1.2 times the 345.6. So we had 345.6 times 1.2. So that would give us 414.72. That would be the next value. Now, that's problem 34. We go to problem 35. What distance will a runner cover in 20 seconds at a rate of 210 meters per minute? So what they want us to do is change this to per second. So with 35, we have 210 meters per 1 minute, even though it says per minute. We have to change the minutes to seconds. So for 1 minute is 60 seconds. So we'll find out how much it is per second, and then we will multiply everything by 20. So let's do this. The minutes will simplify out. It'll be 210 over 60, 210 meters over 60 seconds. So we'll do 210 divided by 60. So it'll be 3.5 meters per second. Now, we want to multiply this by 20 seconds. So we add 3.5 meters over 1 second. and we'll multiply this by 20 seconds. So the seconds will simplify out, and we could take 3.5 times 20, and that'll give us 70 meters. So your answer here is 70 meters. Now that took care of problem 35. Now we go here to problem 36. It says Elaine keeps an investment whose values X years after opening an account can be described by the equation y equals 10,000 times 1.07 to the x. What does the number 1.07 represent? And we could say it's the growth factor. Okay, problem 37. Does the line pictured below has a positive, negative, zero, or undefined slope? Now, whenever we're dealing with a linear equation or a linear graph, we go from left to right like you're reading a book. If the graph is going down, and when I say going down, I'm saying going down on the y-axis. If the graph is going downward, then it's negative. If it's going upward from left to right, then it's positive. So, and we're not going to get into the zero or undefined just yet. But if you notice, going from left to right, it's going down, so it's negative. If it would have been going up, it'd be positive. But then also for the zero slope is basically when you have a horizontal line. Like if the line was going just straight across. The line was going straight across, it'd be zero. But if the line was going vertical, straight up and down, then it would be an undefined slope, just to let you know. Okay, 38. The table below shows the number of women serving in the legislature. For selected years. Find both a linear and an exponential model for the data. Had a slight technical difficulty, but we're back on. Okay, it says find both a linear and an exponential model for the data and decide which model is a better fit for the data. Round coefficients to 5 decimal places. Okay, so we're going to take this Desmos calculator. We're going to go back up here, and we're just going to change this table. Okay, so let me see. I can backtrack here. So we have 0, it'll be 51. And let me do all the x's. So we got 4, 8, 12, 16, 20, 24, 28. Then let me see, we got 38, 34, 32, 33, 30, 26, and 25. Okay, now we go down here and we look at our equations, which we already still had. So we look here and it asks us to find both those models. So we'll write down both. The linear, I just put L and E for exponential. The linear equation is y is equal to a negative 0. It says round to 5 decimal places, 75298x plus 44.1667. Now for the exponential would be 44.4067 times 0.97870 to the x power. Okay, so now we have both equations. Now they also ask us to decide which model is a better fit. Okay, so we could look at our correlation coefficient. This correlation coefficient is a negative 0.9005, and this correlation coefficient is a negative 0.9378. So the exponential is better. is a better fit because it is closer to -1 with a correlation coefficient of R is equal to a negative 0.9378. Okay, now we go here to problem 39. It says determine the slope by using the slope formula at any 2 points on the line. Okay, so if you look here, we got 1 point here, which would be 0, 1. Now we have to find another exact point. Now another exact point is right up here at the top. This would be 2, 5. Now they tell us they want us to determine the slope. So we have 2 points and we could determine the slope. So this right here will be x of 1, y sub 1, x of 2, and y sub 2. So the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 5, y sub 1 is 1. X sub 2 is 2, and x sub 1 is 0. So this will give us 4 over 2, which is 2. So the slope here would be 2. Okay, problem 40. It says an investment whose value is described by the equation y equals 12,500 times 1.03 to the x is left untouched for many years. After 3 generations of inheritance and 98 years, what percent of the original value would the account be? Okay, so there's a couple things that you will have to do here. First thing, we need to substitute in for x 98. And then we need to find out what that value is. So we'll type this right in this calculator. So we had 12,500 parentheses 1.03, and then we would take that to the 98th power. So this would give us $226,442.55. Now we're asked this question. What percent of the original value would the account be? So we're going to have to take this and divide it by the original amount of 12,500. So we'll put this in a calculator, and whatever our answer is, we have to change it to a percent. So it'll be 226,442.55 divided by 12,500. So we have to move that decimal 2 places to the right. So this would give us 1,811, and I'll round to 1 decimal place, 0.5%. So it'd be 1,811.5%. Okay, problem 41. It says for the data points listed below, find the line of best fit and the correlation coefficient. All right, so we need to go back here. We need to go up. So we have 4, 8, 12, 16, 20, 24, and 28. And then for 4 is negative 86, negative 30, 26, 89, negative 44, 56, and negative 54. Okay, now we still have our equations here. We could look at the R values because we just want to find the line of best fit. So the linear is 0.2385, And then if you notice here, this doesn't have an R value. So we will go ahead and use the linear. So it'll be y is equal to 1.76786x minus 34.4286. And that will be our line of best fit. And the correlation coefficient will be R is equal to 0.2385. Now that would take care of problem 41. Now, we got to go back up to problem number 3. That's the problem we skipped over because we needed to draw an equation. Draw the point. So if you look here, it says plot each of the following points on the same set of axes. Okay, so what I'm going to do, I'm going to draw a graph. Oh, you know what? I didn't show problem 41. This was 41. This was the equation, the line of best fit, and this was the correlation coefficient. Now, we're going to go here and do problem number 3. So I'm going to draw a graph here. And let's see. All right. And by the way, on your test, if you have to graph, it'll be graphing right on the computer. You won't have to draw a graph like this. Okay, so we have to graph 3, 5. We start here at the origin where the x-axis and the y-axis meets. We always start at the origin. Remember, x goes left, right, or stay. Y goes up, down, or stay. So we go here to the origin. X is 3, so we'll go 3 to the right. And y is 5, so we'll go 5 up. And remember, you always plot your point where the y ends. So we go back to the origin. We add -2, 1. We'll go to the left 2. And then we'll go up 1. Next, we have 5, 0. So we'll go back to the origin. We'll go 5 to the right. And since y is 0, we'll stay on the x-axis and plot our point. And then finally, 0, -4. We'll start here. We don't move left or right. We stay. But y is -4, so we go down 4. And so now we plotted all of our points. And we're done with the review. And if you have any questions, please contact me. And don't forget to do your 2-7 check assignment today as well.